Before going off and talking about nitrogen-containing compounds, it is worth just revisiting ethanol to point out a couple of other areas of the spectrum. First is this area down here from about 1,000 on downwards. Some would say 11 or 1,200, certainly potentially including the rest of the single bond area. That's called the fingerprint region. There's all kinds of weird, strange peaks in there. It's very distinctive, but it's very hard to interpret. Again, that's something that if you were a heavy-duty spectroscopist, you'd worry about quite a lot. If you were trying to compare two compounds to say, hey, is this one the same as this one, you'd have a look at that fingerprint region. But in terms of just finding fun groups and so forth, identifying what particular bonds are in there, it's not the most useful part of the spectrum. The other part is this bit up here, sort of between about 1,300 and 1,500, that's been there on every single spectrum that we've looked at, and will be there on just about every single spectrum that we do look at from now on. But I've kind of glossed over it, and that's because it's a type of bond vibration that we haven't thought about yet. That's now when we think about vibrational modes of molecules of bonds. We think about stretches, and you can have two types of stretches. So this type of stretch here, which is called a symmetric stretch. So that's an atom that's got two or more bonds associated with it, and they're vibrating in a symmetric fashion. And most of what we look at are symmetric stretches. There's also the possibility of asymmetric stretches. This is not quite as well formed an animation because in speeding up I lost some of its factors, but anyway, that's an asymmetric vibration, and most of the time when we're looking at infrared stretches, we're thinking about vibrations. However, there is a third type of movement that's illustrated with this animation that's called a bending. And these peaks up here that I've circled in red are associated with bends associated with bonds to hydrogen. So you can see this is where the stretches for bonds to hydrogen occur. This is where the bends for bonds to hydrogen occur. And sometimes they're not very important in the spectrum at all. Other times they can even overlay some of the more significant stretches. So anyway, as we go forward, I'm pretty much going to ignore the fingerprint region. In fact, you might have noticed on the spectra up till now, I haven't even included the fingerprint region. And you will always have that bending region.